Okay, we're going to pick up where the previous video left off. We had a little freeze there with our camera, so this is going to be the second part of 4.5. And again, we're trying to find the roots of this polynomial. We have a fourth degree. We're going to use the rational root theorem here, and my constant term a is 2. Factors or integer factors are plus or minus 1 and plus or minus 2. Constant term is 4. Integer factors are plus or minus 1, 2, and 4. So now we'll take each of the integer factors of our constant term divided by the integer factors of the leading coefficient. And when we look at all of our combinations, we have 1 over 1, which is plus or minus 1, plus or minus 1 over 2. Plus or minus 2 over 1, which I don't need to write 2 over 1. We'll just write that as 2. And then plus or minus 2 over 2 is 1. We already have that. We have plus or minus 4 over 1. And then the 4 over 2 we already have here in 2. So here's my list of possible rational roots. I'm going to try 1. And I'm going to use synthetic division. So bring down the first term, multiply and add, multiply and add, multiply and add, multiply and add. Okay, so I could now try another one, but I see a little bit of a pattern here in terms of our numbers. And so what I recognize, and I'll do this down here, is that this fourth degree will factor to x minus 1, and then we'd have 2x squared, cubed rather, plus 1x squared minus 8x minus 4. So what I notice from here is that I can factor these two terms and these two terms, and so we'll be using our grouping. So I can factor out a negative 4, and I'm left with 2x plus 1. And I see from these two terms, if I factor out an x squared, let me get a little bit of a better eraser here. If I factor out an x squared, I'm also left with 2x plus 1. So now I have my x minus 1, factor out, there's my 2x plus 1, and I'm left with x squared minus 4. And then I have a difference of squares there. And so now I can take each factor, set it equal to 0. We're applying the zero product property. And notice we're going to get 4 unique roots here. So 2 and negative 2, 1 and negative 1/2. So anytime I can factor, I want to do that. But let's say I didn't see that. And so after trying 1, I'm going to try 2. So I can use this quotient and do synthetic division again. So I bring down the 2, multiply, add, multiply, add, multiply, add. So again, now I'd have a quadratic, and I could factor that. Or again, let's say I don't see that. I'm going to try now negative 2. So 2, multiply, add, and then my last factor would be 2x plus 1. So get the same results. Again, if you see that you can factor a quotient, do that. If not, continue to use your synthetic division. Choose from your list of rational roots and see where that takes you. Okay, let's look at a problem where we are given some roots and they are asking us to write down a polynomial, what they say is of least degree. So we know that our polynomial will be written in the form x minus the root, so we have x minus 3, then x minus negative 4, which is x plus 4. And now notice we have an irrational root. So one of the things hopefully that you've seen is that all irrational roots come in pairs. We call those conjugates. So if we have root 5, we also have to have negative root 5. And so we'd have x minus root 5 and x minus negative or x plus root 5. And then normally we would write this we'd multiply here, and you'd end up with x squared minus 5, which when you set this factor equal to 0, there's where your root 5 and negative root 5 comes from. And here we have another one. I'll use g of x. Since I have 0 as a root, we'll have x as a factor. We have negative 1, so we have x minus that, or x plus 1. And again, because I have 1 minus root 3, I also have to have 1 plus root 3. I have to have its conjugate. So now I would write this as x minus 1 minus root 3, x minus 1 plus root 3. And I do want to clean this up here a little bit for our purposes. So here's what I'm going to do. I'm going to distribute the negative. So I'll do that right here so you see what that looks like. And then notice I have the x minus 1s. And I have that again. And so hopefully what you see is what we have is a difference of squares here, in terms of a factored form of difference of squares, right? A plus B, A minus B. And this is just helping me out in my foiling. So I know that I'm going to get A squared minus B squared. So I have x minus 1 squared. I really shouldn't have had the squared there. My apologies. I was getting a step ahead of myself there in terms of our squaring down there. It's really just the x minus 1 that we're grouping minus the root 3 squared. So we have x plus 1. When we expand this, x squared minus 2x plus 1, root 3 squared is going to be 3. And so x squared minus 2x minus 2. So there's a polynomial which has these as its roots. Notice we'd have a 4th degree. They gave us 3 roots, but we know we have to have that conjugate for the irrational root. Hope that helps, and we'll see you soon.